Assalamu alaikum. Welcome to you all. In this video, we will explore the binary search algorithm with a detailed implementation in the Java programming language. We will see how it can optimize our search operations in sorted datasets. Since this is an implementation-oriented video and our primary goal is to walk through the process of coding the binary search algorithm, I hope you are already familiar with the concept, which will help us jump straight into the implementation. Let us take a moment to remind ourselves of the basic conceptual understanding of this algorithm. As we know, binary search is an efficient searching algorithm that works only on sorted data. So if we ask, how does binary search work? The answer would be like, it begins by taking the start and end of the array, then calculating the middle index. The target value is compared with the middle element. Based on the comparison, it eliminates either the left or right half of the array and repeats until the target is found or the loop ends. That's the main concept here. Based on this concept, we can now see an algorithm that will enable us to implement binary search in any programming language. The binary search function starts with two pointers, start and the end. While start is less than or equal to end, indicating that there are elements left to check within the array, the function calculates the midpoint by adding the start and end and dividing it by 2. If the value at the mid index matches the target, it returns the mid. If the target is smaller, the function updates the end to mid minus 1 index. If it's larger, it moves the start to mid plus 1 index. If the loop ends without finding the target, the function returns -1. This is Mushfiq, excited to guide you through the implementation of binary search in Java. Before we dive in, you are welcome to connect with me through my social networks. And let's get started with the coding. First of all, let us create a folder named the algorithm. Okay, now go to the Visual Studio Code to implement the binary search algorithm. As we are implementing this algorithm in Java, so our extension will be .java. Okay, in Java, first of all, we have to declare our class with the file name, public class binary search. Then in this program, as we will take the input from the user, so we have to import the scanner class from the Java util package, which will help us to read the inputs from the user. So import java.util package and this scanner class. That's it. Now, before starting this program, we know we have to write our main function. Public static void main. Okay, that's it. Now, first of all, we have to create a scanner object here. Suppose we name it scan. Okay, new scanner. Now let's give a message to the user that we need the total number of the elements. Okay, system dot out dot println. Okay, enter the total number of elements. So let's create a variable named n, and here we use our scanner object with next int. This line will take the input from the console. Okay, by this number let's create an array named a new int and give the size n that we have received. Okay, now it's time to enter the elements here. Enter the elements. So to take elements into array, we have to use a for loop. Integer I starting from the 0 until is less than n and I plus plus. Then the array index, and again we will use our scanner object to take the input from the user. Okay, now at this point, suppose the elements that we received from the user is not sorted, but we have see that we need a sorted data sets to apply the binary search. So now what we have to do to sort our data if it's not sorted? In Java, we will use a function that is arrays dot sort. Arrays dot sort. This will sort our all array elements in just a single line. But to this we have to import our arrays class from the util package. Arrays. That's it. Now we can print the sorted array. Suppose sorted elements. Again we have to give the for loop. Plus plus. And then we'll print them by index. And just it. Okay. Then just give a empty line to make the program more clear. Okay, in this stage now we don't know which value we have to find, so let's take a variable m. Before that print a message that we need the value to search. Enter the element to search, the element to search. Okay, now let's store it in variable m and scan object again, next int. Okay, now we have our sorted data and also we have the element that needs to be searched. So now what to do? Now we will create another method which will perform this binary search for us. So let's call this function by creating an object of this class by binary search. Suppose we name this function b, I mean the object b, then new binary search. So we have created an object of this class which is named b search. Then let's call this function and store their returned value in a single variable named result. Okay, we will store our returned value here. Now call that function. Suppose we name that function binary search. Binary search is search. Okay, so I think we need to pass some parameters with that function. By that, the function will know the resources. First of all, we have to pass our array. Then, as we learned from the algorithm, we have to pass our starting index, which is 0. Then, suppose the ending index, which is n-1, because our array starts from 0. So we have passed first start and end element, then the element that we have to found. Okay, that's it. Now we have to create another method. Suppose we'll create it here and it will be a integer because it will return integer value. Then the method name binary search. Now the parameters. First we have taken integer array. Okay, then integer value start, name it start, then we give a name that end, and then our m, which is the value we need to search here. Okay, so at this point from the algorithm we know first of all we have to traverse our full array, and we can do this by a single loop, while loop. In this while loop, start is less than equal to end, which means our this loop will go through all the elements of the array until the start is less than or equal to end. Okay, from the algorithm we know now we have to find the middle index of this array. So how can we do that? We can do it by adding the start and end value and then dividing them by 2. Now we have the mid value in our hand. Okay, now from the algorithm we know first of all we have to check that if the mid element is our target element or not. So how can we write that? We will write the a and the mid index is equal to m. So this will happen when our array will divide into sub arrays and it becomes smaller, and if the element is present in the array in some time at a time, our mid value will be the targeted value when our array gets smaller. So we have to return our mid if our mid value is our targeted value. So it's no other option, we will return our mid value to the main function. And if it's not the mid value, what we have to do, we know from the algorithm, we have to check if our targeted value is smaller than the mid or larger than the mid. So let's think it is smaller than the mid. If it's smaller than the mid, then we have to divide our array into a half part. Okay, so we will have to update our end position with the mid position. We know the mid, so it will be mid minus 1 because we have a mid value. We have checked this mid value in this if condition. So we will check, we will give mid minus 1 to this value, and that's by this thing our array become divided into two parts. Okay, so by this thing, if what happens if our targeted value is larger than the mid, then we'll give another condition else and update our start with mid value, and we have, as we have searched our mid value there, so it will be mid plus 1. That's it. These things we have learned from our algorithm that first of all we have to check if our mid value is the target value or not, and then we have to check if it is larger than the mid or it is smaller than the mid. If it is larger than the mid, so we'll update our start value to mid plus 1, and it is smaller, then we'll update our end with mid minus 1 index. So our loop will go through this array with each iterations and divide our array into subparts by subparts, and at a moment it will be return our mid when it founds the value actually. Then the array will be sorted, array will be more sorted, and then our mid value will be our targeted value and it will return our mid. So what happens if our element is not present in this array? So it will go out from this loop and then it will return minus 1. Yes, right. If our element is not present here, it will return minus 1 coming out from the loop. Okay, so now let's come to our main function. So now we have a value in our this result variable that is minus 1 or the actual index of our element. So how can we show that to our user? First of all, let us write the result is equal to minus 1. If the result returns minus 1, that means our element is not present in this array. So simply we'll give this message to the user, element not found, okay. Element not found, and we know if it's not minus 1, that means we have the actual value in our hand. So we'll print this thing, print that index by else, and then we will print the message. Suppose as we have the elements index in our hand, so let's print that element found at index, and now we give the result here, because if it is not minus 1, that means if it is the right index, it is carrying the right index of the searching value. So that's it. By this line our program is totally finished. So now check this whether it is running correctly or not. Okay, let's compile this program. Java C binary search. Okay, it is compiled successfully. Let's run this compiled program. Okay, so it's telling us to enter the total number of the elements. Suppose it is 7. Okay, now it's time to enter the elements. Suppose it is 78, 34, 12, 99. Okay, now it sorts all the elements. We can see sorted elements here. Now we have to enter the element to search. Okay, suppose we want to search 43. So it's our answer, element found at index 2. As we know, array index starts from 0, 0, 1 and 2. Yes, our program is running correctly. So the implementation of binary search is successfully executed. So it's the Java program. As we see, we have imported the scanner class here, also the arrays to sort the arrays. Then from the main method, we have created an object of scanner class. Then we take the total number of elements of the array. Then we declare array, take the array inputs, then we sort the array. Then we show the sorted array to the user. Okay, space line. Then we take the element that we want to search. Then we create an object of this class named b. We stored the return value of the binary search function in the result variable, and that is our binary search algorithm most probably applied in this function, and we have discussed it previously in this video. The algorithm of binary search, first of all, it travels all the array through this loop. First of all, it determines the mid value, then compare it with the mid. If it's not, then it divides our array into sub-array parts until the loop goes to its second iteration, third iteration, and at a time our targeted element comes to the mid position, and it will return the mid. If it is not present in this array, then it comes out to the loop and prints and returns -1. So it will return either mid or either -1. So after this, we just simply printed that message. Our result is, if it is -1, that means element is not found, and if it is the correct element, we print that element found at index and the index number. And that's it. It's the binary search algorithm that we have implement. Thanks to you all for hearing me with patience. Assalamu alaikum.